Closed tubes. Let's move on to air columns that are formed in a closed tube. And we're going to define a tube that's closed at one end. We'll have a displacement node right here at the closed end for your sound waves there. They're kind of fixed to the wall. Then at the other end, it's free to move. So that's going to be an antinode, a displacement antinode. That's where it's open up to the atmosphere. And of course, where you have a displacement node, you have a pressure antinode. And where you have a displacement antinode over here, you have a pressure node. Okay, so let's go ahead and erase this. There we go. Let's look at what kind of waves we can form. Well, the first one that we can form, we start at the node here, and we go up to an antinode. And we're going to claim that's 1/4 of a wave. Why? Well, let's show a wave here. Okay. Here's our wave, like this. This is one complete wave. So what do we have? This over here, we go up and we don't come down. So that's right there. How much of the wavelength is that? Well, that's 1/4. So if we wanted to find out what the wavelength of this first wave, which takes up a distance L, the length of this pipe is L, and we'll write that down there. So lambda in that case will be 1, 2, 3, 4. 4 times L. So lambda is equal to 4L. So frequency is velocity over lambda. So this will be V over 4L. And we'll call that our fundamental frequency, where N is going to be 1. Now what's the next kind of wave we can fit? Remember, we have to have a node at the left side and an antinode at the right. Well, we start again, we go up, we come down. We've still only hit one antinode. We need to get another one. So we go down one more time over to here. What does that look like on this picture? Well, let's take a different color here, green. We go up, we come down, and then we stop here. How much of the wave do we have this time? We have 3/4 of it, okay? Because another quarter, we'd have the full wave. So we have 3/4 of a wave. That means the lambda is 4/3 times L. You just take the reciprocal. So we plug that in to our frequency equation, and we get 3V over 4L. What is that? That's 3 times your fundamental frequency. So this is going to be N equals 3. So already we're seeing a pattern. We don't have N equal 2, do we? Let's go to the next wave. And let's change the color, and we'll go to purple here. We need again to have a node at one end and an antinode at the other. So we go up, down, we find one node there. Here's another antinode. We keep going. We want to find another antinode because it's open on that side. And in this case, it looks like we fit 5/4 of a wave inside this pipe. We came like this, up, down, and then we kept on going to the next antinode. That's 5/4. So this time the wavelength is 4/5 L, right? The wavelength stops right here, and that's 4/5 of that length. So we now have frequency is velocity over lambda, 5V over 4L, and we note that N is equal to 5 this time times the fundamental frequency. It looks like we're only having odd numbers. Let's look at that fundamental frequency again, that first wave that fit into our pipe. Okay, we have our pipe of length L over here, and we know we start with a node at the closed end, and then we have an antinode at the open end. So the first part of the wave goes like this. Then since we need a complete wave, we start coming down to here, and what do we find over here? We find another node. We don't have a full wave yet. We now have to go below that, and we come over here. We have another, what do we have right there? We have another antinode. So I didn't label the antinode over there. And then we come back up here to our node. We now have a complete wave. And what are the distances between these points? Each one has a distance L. So the total length is 4L. So we find that the wavelength is equal to 4 times L, where N in this first one is N equal 1. So lambda 1 is going to be 4L over 1, or just 4L. We found that on the previous slide. Then we did the next few, and we found that the next frequencies were proportional to f1, but this n was only equal to 3, 5, and then if we kept going, we would find n is equal to 7, 9, etc. So the frequencies for this closed tube, we have our fundamental frequency. Okay, and what's the fundamental frequency there? That would be right here. Okay, would be n is equal to 1. We have the velocity of the wave divided by 4L, and we call f1, our fundamental frequency, is the velocity over 4L. Then the next frequency comes when n is equal to 3. And then the next one comes when n is equal to 5, and like we just said, we can imagine this would keep on going. So those are the possible frequencies in a closed tube.